Today we're going to learn about enthalpy, and it's a kind of a strange word, but it has to do with energy. That's our what we're talking about. Uh, this is one that is applied specifically to chemistry, and it has to do with the energy of the system. And the definition for enthalpy is simply that it's the energy of the system plus the product of the pressure and the volume of the system. Right? It's written out as H. H is the symbol that we use for enthalpy, and that's equal to the energy plus the pressure times the volume. Now, we run into some issues with trying to figure out the absolute value for the enthalpy of the system. It's actually not possible to do that. And so rather than it doesn't really give us any useful information. So what we do instead is we use a term called the change in enthalpy. And this is used far more often, and it's far more useful to us in most cases. So we use delta H to represent the change in enthalpy. With chemical systems in the lab, we normally deal with open systems. Once in a while, a closed system, and it's pretty almost impossible to get a totally isolated system. So the heat exchanged between the system and the surroundings is really what we're looking at. Is how does that energy flow between the system and its surroundings? And that change is what we call the enthalpy change of the system. It's written as delta H. Sometimes it's the change in energy. It's also known as heat, or Q. And so you'll hear those terms a fair bit as well. Now, because it's pressure dependent, we also generally need to standardize our values that we're given. So if you look up a table of change in enthalpy of, let's say, a reaction or a heat of formation or something like that, what will usually happen is that there will be a set of conditions attached to that, because the delta H changes with how the pressure changes and how the temperature or how the volume of the system is changed as well. And so we just standardize things usually to 1 atmosphere of pressure and volume to 1 liter or something like that. Usually the tables will tell you what those standard conditions are. If we have an increase in the enthalpy, then what's happening is that the enthalpy of the system is increasing. So energy is being added to the system from the surroundings. And that's a situation which we call an endothermic process. Similarly, if the system itself loses energy, so the energy is leaving the system going to the surroundings, then you have a situation that is exothermic. It's important to make sure that you understand how these two relationships, how these two terms are represented by the delta H values. Signs are very important. And the change is always relative to the system. And so it's really important to be able to identify, okay, what's the system, what's the surroundings? All right, we get to the second law of thermodynamics, which states that when two objects are in thermal contact, heat always flows from the hotter object to the colder object. And it will continue to do so until the two objects are at the same temperature. Now, we take a look at our enthalpy changes, and we usually categorize them. Chemists like to put things in order, and so we generally categorize the delta H value based on what type of an energy change is involved. So we can have things like physical changes, state changes, that sort of thing. We can have nuclear changes, and then we can have chemical changes, so chemical reactions of different sorts. And so quite often you will see a subscript attached to the delta H value that will indicate what type of process, what type of enthalpy change you're actually looking at. That's important because now we can identify specifically the enthalpy change that we're looking at. So heat of vaporization or enthalpy change of vaporization is delta H VAP. Solution, if you're dissolving something, delta H of solution for enthalpy of solution. And then combustion, for example, delta H COMB. Those symbols are quite often used for these sorts of things. Okay, some textbooks will use a greater variety of these subscripts, and some textbooks kind of limit themselves to only just a few. Kind of depends what we're doing. Now, one of the things that we will notice as we go through our textbook, and if you happen to have different textbooks at home, different textbooks look at the terminology a little bit differently. There are some older textbooks that use the term enthalpy very sparingly. In fact, most of the time they just call it heat. So delta H of melting, for example, would be called the heat of melting, or the heat of freezing, or the heat of fusion, which sums up actually both of those. And so you just have to get used to using the symbols that are at hand and making do with that sort of thing. Okay. All right, so this week's homework. So with these questions and all the other stuff that we've done in the first note, that should be enough for the 3 hours for this week. Good luck.